All right, we're going to do the first free response problem from review day 16. We're given this graph. And this graph a little different this time. They give us a part of a circle, but this time they turn the circle over from what we're used to. They're saying the center is up here. Obviously has a radius of 3, but we're going to be interested in this right here eventually. So just kind of looking ahead, the circle would have a radius of, an area of 9 pi, which means this part would be 9 pi over 4, but that's not the area that we're going to be working with. We're going to be working with this right here. So if you think of it as a whole square, the whole square would have an area of 9. This part's 9 pi over 4, and that's what we don't want. So this area in here is going to be 9 minus 9 pi over 4. Again, just kind of looking ahead. And then we have this triangle and this triangle kind of knocking each other out, so they kind of cancel, which leaves us with this trapezoid. 1 plus 3 is 4, times 1 divided by 2 would give us an area of 2 here. Okay, and then this triangle and this triangle kind of knock each other out too, right? So in terms of kind of looking at the areas of what we're working with, that's what we see. Now, right away it comes in, but it's not directly. They don't just ask directly for this area, even though that is in a sense what they're trying to get to. They say that the area from -6 to 5, so from some point over here to 5, that total area is 7. They want you to find the area from -6 to -2 then, based on that. So in other words, what they want to see if we understand is, do we know that the area from -6 to 5 is equal to the area from -6 to -2 plus the area from -2 to 5? And if you wrote that or you had that on your paper, you got a point for understanding that. Okay? So then let's go ahead and sub in. They told us this part is 7. This is what we're, equals. This is what we're looking for. And now this area is what we can get off of the graph here. So we already said that this positive, this negative cancel, this negative, this positive cancel. And so that leaves us with 2 plus 9 minus 9 pi over 4. So that's 11 minus 9 pi over 4. If you had that area, that was worth a point. And then what we'd want to do is subtract that from here. So the integral, or the area from -6 to -2 of this function would be positive 9 pi over 4 and then minus 4. All right, and that would be worth a final point. So we had to really understand kind of what they were asking for here, but then that's, once we understand it, it's not too bad. Part B wants us to evaluate this right here, and I think it's just best if we go ahead and integrate that. So that's going to integrate to 2f of x plus 4x. So I'm integrating both parts of that, and we're going to do that from 3 to 5. So if you had that, that was worth a point. And then we're going to go ahead and put 5 in there. So it's going to be 2 times f of 5. This is f, and f of 5 is 0, plus 4 times 5, okay, minus, and then we're going to put 3 in, so it's going to be 2 times f of 3, which is this crazy 3 minus square root of 5, plus 4 times 3, which is 12, okay? Put a little divider here for us. So again, we integrated this, and then we threw 5 and 3 in and got here. And if we want to go a little bit further, it would be 20 minus 12, which is 8, and then minus 6, which is going to give us 2. And then it's going to be a minus 2 times a negative square root of 5, which would become a positive 2 square root of 5. So you can do that in a couple more steps. I kind of jumped ahead a little bit. But that would be our simplified answer. Now, to be honest with you, if you have this, I believe that gets you full credit as well, because that is technically the answer. So you don't even want to mess around with all that multiplying. I don't believe you're going to have to. C says the function g is the integral of this. Can we find the maximum value of g from -2 to 5? So if we're looking at from -2 to 5, we can see that initially, well, first off, g prime, the derivative of that, would be the derivative of this, which would just be the f function, right? So this is going to act as the derivative of g, which is important then, because then that means when this is positive, g is increasing, right? And when this is negative, g is decreasing. So if we're talking about the maximum is going to occur at possibly a relative maximum. So g has a relative max at x equal -1, because that's where g prime x, which equals f of x, switches from positive to negative. Okay, and then later on we have a relative minimum here, but then as we keep going, we'll see that we're increasing this whole time, and then 5 is possibly a place where it might be. So what we're going to say is that g has a relative maximum at -1. That's a possibility. Other possibility is x equal 5, because g is increasing up to x equal 5. So something like that. So what they did was they gave you a point for expressing the derivative of g is f, and they gave you a point for recognizing that -1 would be a possibility. What you had to do at this point then was test those two. Okay, so what about them? Which one is going to be our answer, right? So if we put -1 and we're going from -2 to -1, that's easy enough. That area is just going to be 1/2. Okay, but if we go from -2 to 5, well, that was actually done up here, right? That was 11 minus 9 pi over 4. All right, so now the question is, well, which one of these is bigger, right? So it's going to require a little bit of just kind of thinking through. Pi we know is about 3, a little over 3. 9/4 is 2 1/4. So if I do 2.25 times about 3, I'm going to get 6.75-ish, right? And 11 minus 6.75-ish will be about 5-ish right here. I might be a little off on the 5, but you know what? It's going to be close, and that's certainly bigger than 1/2. So our absolute max is 11 minus 9 pi over 4. And if we had that, that was worth a point. Okay, so we can do the value, but if you don't know how it compares to 1/2, it did us no good, right? Then we get D, and D is kind of crazy. It says find the limit as x approaches 1 of this. And at first it makes you feel like you're going to have to do L'Hopital's. And if you went and tried to do L'Hopital, you did a lot more work than you needed to. Really, every time you see a limit, the first thing you should do is plug it in. And so for D, if I plug that in, I'm going to get 10 to the first, which is 10, minus 3 times f prime of 1. F prime of 1 is the slope of this line up here. And that slope is just 2. So right away you can see L'Hopital is not going to work because I don't get 0 on the top. All right, so that's the whole point of that. And then down here we have f of 1. So f of 1 is where is it actually at, and that's at a value of 1. And the arctan of 1 is asking what angle has a tangent equal to 1. And in order for it to have a tangent equal to 1, your opposite and your adjacent have to be the same thing. So that's actually pi over 4. And so I end up with 4 over 1 minus pi over 4. And while that looks weird, that actually is your answer, and you got a point for that.